Heyo, Sim Science time. So glad you guys are here. I'm here about to pop off one of the most anticipated videos of 2019. I'm going to go over all these problems. So, if you got your problems back, I graded them all. Okay, your homework, whatever it was. If you see a specific one that you want to see the answer to, then skip to it. You know, if you want to watch them all, just because the pure entertainment value Sim Science offers, then by all means. But this is just a walkthrough step by step each one of these problems, and you can do whatever you like with this video. A lot of you were messing up with sig figs, so that's just something to be mindful of. Anyway, let's just jump in, okay? So our first problem here, let's break it down. What is R known? What do we know? Well, we're told that we have a number. Whenever you see a number, beep, 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 there's your known number. Okay, we have this many molecules of water. 1.345 times 10 to the 15th molecules of water. Okay, good stuff, good stuff. Our unknown, our needed, what we're trying to find is going to be what you're asked to do. So calculate number of moles of water. Okay, now we got to figure out what we're going to use to get between these things, or how we're going to find what we use. Now, a lot of you were thrown off by this problem. You started trying to calculate the mass of water, and I'll be honest, I was inclined to do that the first time I looked at this as well. But let's look at what we're going between here. We're going between molecules and moles. Molecules in this case are also could be called particles. So how many of these, or how many moles do you have from this? So molecules to moles is going to be particles to moles. And particles to moles is always 6.02 times 10 to the 23rd particles per 1 mole. In this case, the particles are molecules of water, and we're dealing with moles of water. Okay, so now we have our known, our unknown, and our conversion factor. And if I was going hard, I could have done these all in different colors. Maybe I'll do that for the rest of them. Too late now, we're in too deep. Okay, so we're going to take our known, 1.345 times 10 to the 15th molecules of water. And we need to multiply that by our conversion factor. We need to multiply by our conversion factor so that we go from our known, which is molecules, to our needed, which is moles. So I need to cancel molecules. I'm always canceling whatever's in my known. So I know that molecules of H2O is going to go on the bottom. We've got to drop it like it's hot. That mathematically is how these are going to cancel. So now I look at my conversion factor, and I see that molecules is here in the denominator with that big number. So 6.02 times 10 to the 23rd, avocado's number, and then 1 mole of water per that many molecules. So now I know that molecules is going to cancel. I'm going to be left with moles of H2O. So now I do the division. If you were struggling plugging this into your calculator, review that. Make sure you know how to plug scientific notation into your calculator. Okay, so after you plug this in, depending on the calculator you're using, you're going to get something like 0.0. Okay, if you have a more advanced calculator, you'll probably get something like that. Okay, now as far as significant figures, we have 4 here and 3 here, so we're only going to be able to keep 3. So I already know that I can get rid of this 4 because I'm not going to be able to keep that. All these zeros are leading zeros, which are never significant if you need to review that. Anyway, here's my answer. Because I did 1.35 times 10 to the 15th multiplied by 1 divided by 6.02 times to the 23rd, and I get this. Now I need to write this in scientific notation. Okay, now to write something in scientific notation, it's always a whole number less than 10, and then the decimal point. Always number, decimal point, and then any other significant figure numbers, and then times 10 to whatever you need to. Okay, so for this case, my first whole number less than 10 is 2. I'm doing 2.23 times 10. Now what's it going to be? So my decimal is here. So it'd be here in this, and I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay, I'm moving my decimal 9 places. Now, is this number, is this going to be a negative or positive exponent? So I know it's going to be a 9, but is it negative or positive 9? Well, is this number here greater than or less than 1? Because if it's greater than 1, the exponent is positive, and if it's less than 1, the exponent is negative. Obviously, this is less than 1, so it's going to be negative. Okay, the other way you can tell is if you look at this decimal here, and then you go here, and when you're moving it from this position, if you're going left, it's going to be negative. If you're going right, it's going to be positive. But that can get tricky because you might start here and say, okay, how do I get it back to here? And you go 1, 2, 3, you go 9 and to the right. So anyway, it's less than 1, the exponent's negative. So my final answer is this many moles of water. Okay, this is my answer for the first one. That many moles of water. Okay, known, unknown, conversion factor, multiply, get it. Okay, number of grams and 0.35 moles of lithium chloride. Okay, I'm gonna make this a little bit smaller. Okay, so first of all, let's do our known. Our known, again, is usually pretty much always gonna be the number you're given. So 0.35 moles of lithium chloride, LiCl. Okay, now I'll start mixing up colors. Our unknown, what we're asked to find, we're calculate number of grams of lithium chloride. So we're trying to find grams of lithium chloride. Now our conversion factor, let's create a new color real quick, just for kicks and gigs. Let's go nice dark green. Okay, now our conversion factor, okay, is going to be how we relate moles to grams of lithium chloride. So that's going to take a quick breakdown here. Lithium chloride, I have Li once 6.94 is the molar mass. Chlorine once is 35.45. I add these up, and I'm going to get 42.39 grams per mole. So this is my molar mass of lithium chloride, which comes in grams per mole. Yay, a conversion factor built in. 42.39 grams per every 1 mole. So there's our conversion factor. That's how we can relate moles to grams, grams to moles. So now we just got to slap this bad boy down. Okay, our known comes first, 0.35 moles of lithium chloride, and if you like it, you can make this over 1, so you can start building your railroad tracks, as they call it. Okay, now we need to multiply by our conversion factor, okay, which we're going to set up, and we need moles of lithium chloride to answer. We're trying to cancel. We're going from moles to grams, so we know that moles of LiCl goes down here. When we look at our conversion factor, I should have written this here. I should have written this here to be specific. So 1 mole for every 42.39 grams of lithium chloride. That's going to allow us to cancel out moles of lithium chloride. Okay, so then it just turns into 0.35 times 42.39, which makes sense because we have that many moles, there's that many in each mole, so it's just a multiplication. So we multiply that, and we are going to get, let me see if the answer would have, however many digits you get. Let's just, before I even say this, let's look at how many significant figures we can keep. 0.35, 42.39, so we have 4 in 42.39, but we only have 2 in 0.35, so we can only keep 2. We're only keeping 2, so that's going to come out to be 15 grams of lithium chloride. There's our unknown. We just multiply, and we get our answer. Okay, 15 grams of lithium chloride. Ooh, how fun is this one, huh? First, we got to balance our equation. I heard that's how the kids are saying it these days. So let's break down this equation hard. So we have, I'm going to rewrite it because there should have been space for a coefficient in front of the H2. So on this side we have nitrogen, hydrogen. On this side we have nitrogen, hydrogen. 2 here, 2 here, 1 here, 3 here. Okay, so first of all, let's even out nitrogen. So we have to make this 2. Now we have 2 nitrogens. That's going to make this 6. Okay, so now nitrogen is balanced, but hydrogen isn't. So we just need to toss a 3 out here, and that balances it. Okay, so this is my balanced equation right here. Nice little balance action. Okay, so now let's get into this itself. Our known is, again, what you're given numerically, 15 moles of NH3. Known, 15 moles ammonia. Okay, now our unknown, yeah, blue. Our unknown, what we're trying to find out, calculate number of moles. So we have, oh, okay, yeah, so moles of nitrogen. So our unknown is moles of N2, because nitrogen is diatomic and it exists here as N2. This is going to be important in a second. Okay, and our conversion factor. So a lot of you had trouble with this conversion factor situation here. I think it's one of the simpler ones because there's really no calculation, it's just a ratio. So in this equation, in this balanced equation, how many moles of nitrogen produce how many moles of NH3? You just have to look at the ratio. So here I have, oh, I'm sorry. This is a mistake a lot of people made actually, is they looked at hydrogen instead of nitrogen, the mistake I just made. So I look at N2 here, then I look at NH3 over here. And I'm looking at my coefficients. So my imaginary 1 there and the 2 there. So I know that for every 1 mole of nitrogen, I produce 2 moles of NH3. Okay, it's just the ratio of my coefficients. That's all it is. Okay, so I just have to take that ratio. That's all I need to do. So I'm going to put my known out front, 15 moles of NH3. I'm going to multiply this by my conversion factor. Okay, so I know that I'm trying to cancel moles of NH3 because that's my given, and I want to end up with moles of nitrogen. So moles of NH3 has to be on the bottom here. I look at my conversion factor. That's how it's already set up. All right, so this is going to allow me to convert between moles of NH3 and moles of nitrogen. So my moles of NH3 is going to cancel. I'm left with 15 times 1 divided by 2. So 15 divided by 2 is going to equal 7.5 moles of N2. Okay. Conversion factors don't really play a role here because we're talking about moles, which is a set unit. You might remember that from conversion factor rules. So these aren't calculations, scientific numbers. These are exact units. Okay, moving on to number 4, Bobby Orr. None of you probably get that reference at all. That's all right. Okay. This time I'm going to try and color code it by the thing we're actually talking about. So I'm going to go back to my primary colors. So our known, first of all, known, let's look for a number. Here's a number. Okay, our known is that we have 36.67 moles of oxygen gas. Okay, our unknown, oh, I'm sorry. Oh, look at this cool feature I found. Okay, so if I want to make, when we talk about oxygen, I want it to be, let's make, what is oxygen usually? Blue? Shoot. Hydrogen's usually red. Oxygen's usually, we'll make it blue. I don't know, I can't remember if that's right though. All I have to do is this. This is so cool, guys. Boom, now it's blue. Ah, awesome. Okay, unknown. Our unknown, what we're trying to find, calculate number of liters. So we're trying to find liters of oxygen. Okay, so if that's blue, we'll make liters of oxygen green, liters of oxygen, and our conversion factor, okay, is going to be how we go between moles of oxygen gas and liters. So we know that every 1 mole of oxygen gas, so I'll keep moles of oxygen in the same blue. Is it the same blue? That's a darker blue. Okay, kind of zoning out. Okay, for every 1 mole of oxygen gas, we have 22.4 liters of O2. Okay, so that's just, it's like Avogadro's number, but for gases, 22.4 liters per every 1 mole. All right, now we're ready to set this up. So we take our known, 36.67 moles of oxygen. Okay, we need to multiply that by our conversion factor, our properly set up conversion factor. So I know that I have moles of oxygen here. I want to cancel moles of oxygen. So I'm going to put it down here, and I know I'm going to look at my conversion factor. I have 1 mole of oxygen for every 22.4 liters of oxygen. Okay, so that's going to cancel out my moles of oxygen, and then my math is just going to be 36.67 times 22.4 divided by 1. Okay, in significant figures, I'm only going to be able to keep, I have 4 here, I have 3 here, so I'm only able to keep 3. So it's going to be, you get 821.4 or something, but we can only keep 3, so we're going to round it to 821 liters of oxygen. Okay, so here's the answer here. I guess I should, I love this new feature I've discovered. Okay, liters of oxygen. All right, on to number 5. Okay, so in this case, our known, 0.35 moles known, 0.35, and I will change the color in a second because I have the power to do that now, moles of lithium carbonate. Okay, so Li2CO3. You would, to write that out, hopefully you're able to write that out if you look at lithium and carbonate. So we will make this, oh, that's weird. We'll make this a nice pastel color. Okay, now our unknown number of molecules we're trying to find, the number of molecules of lithium carbonate. Okay, so that means that our conversion factor has to allow us to go in between moles and molecules of lithium carbonate. And again, you don't have to calculate the mass of it or anything because we know how to go between moles and molecules, because for every 1 mole of lithium carbonate, we will always have 6.02 times 10 to the 23rd molecules of lithium carbonate. Okay, so we have everything we need once again. So we're going to multiply our known, which is 0.35 moles of lithium carbonate. We're going to multiply that by our conversion factor. We need moles of lithium carbonate to cancel, so it goes down here. Okay, and so we look at our conversion factor. It's 1 mole of lithium carbonate for every 6.02 times 10 to the 23rd molecules of lithium carbonate. Okay, so we just do the math on that. It's going to be 0.35 times 6.02 times 10 to the 23rd. Okay, and we get how many we convert or significant figures 0.35, 6.02. So we're only able to keep 2. So we're going to get 2.1 times 10 to the 23rd. Molecules of lithium carbonate. Okay, and we know that because our moles cancel and we're just left with molecules of lithium carbonate. Okay, there's a lot of these and I'm zoning out. Plan on doing them all at once. I'm gonna take a break, get some water. I will be back before